In the autumn of 1943, in a brightly lit sterile laboratory, deep within the Third Reich, a group of men gathered around a large metal table. These were not soldiers in the traditional sense. They wore lab coats, not field gray uniforms. Their weapons were calipers, spectrographs, and slide rules. Their minds, honed by the finest technical universities in Germany, were the sharpest intellectual instruments in Hitler's vast war machine. They were the men tasked with dissecting the future with reverse engineering victory. For months they had pieced together a puzzle from thousands of shattered fragments recovered from the fields and forests of occupied Europe. Mangled pieces of aluminum, twisted propellers, and burnt-out engines from downed American bombers. From this wreckage, they had formed a picture, an incomplete but terrifying mosaic of their enemy's industrial power. But it was just a ghost. They needed a body. They needed a complete, intact specimen of the machine that was beginning to methodically bleed their nation to death from 5 miles above the earth. They needed a Boeing B-17 flying fortress. The B-17 was more than an airplane to these men. It was an obsession. It was an affront to their entire engineering philosophy. German design was a creed of elegant, high-performance, and often complex masterpieces. Their Messerschmitt Bf 109 was a scalpel, a thoroughbred born from a racing pedigree. Their Focke-Wulf FW 190 was a beast, a radial engine brawler that pilots loved for its ruggedness and devastating firepower. These were aircraft built by craftsmen designed for duels. The B-17, in contrast, seemed to them a flying contradiction. It was huge, lumbering, and by their standards, aesthetically uninspired. They derisively called it the arrogant aluminum cigar. It seemed to be a product not of artists, but of plumbers and factory foremen. A brute force solution to a delicate problem. Yet this clumsy giant was doing something their finest minds were struggling to comprehend. It was operating with impunity in a realm they considered their own, the cold, thin air of the stratosphere. The secret, they knew, was not in its shape or its size, but in its breath. The high-altitude performance of any piston engine is a battle against asphyxiation. As an aircraft climbs, the air thins, and the engine is starved of the oxygen it needs to burn fuel and create power. The German solution to this problem was a testament to their love of mechanical intricacy. They had developed astonishingly complex gear-driven superchargers. These were like mechanical lungs, using the engine's own power to force-feed compressed air into the cylinders. They were marvels of precision engineering, but they were also parasites. They stole a significant amount of power from the engine just to function. And above 25,000 feet, they too began to gasp for air, their efficiency plummeting. Their fighters, the pride of the Luftwaffe, became sluggish and unresponsive in the high altitudes where the B-17s seemed to cruise with an unnatural ease. From wreckage analysis and pilot reports, the German engineers knew the Americans used a different system, a turbosupercharger. The concept was not new. German engineers themselves had experimented with it. The idea was to use the engine's hot wasted exhaust gas to spin a turbine, which in turn would drive a compressor to pump air into the engine. It was a closed loop of energy, a seemingly perfect solution that turned waste into power, but in practice it was a metallurgical nightmare. The turbine wheel had to withstand temperatures that could melt steel and spin at speeds that would tear lesser metals apart. The German attempts had failed, plagued by overheating, material failures, and catastrophic disintegration. They had concluded with their characteristic scientific certainty that the technology was too unreliable, too dangerous for mass production in a frontline combat aircraft. It was a dead end. Yet every day the evidence to the contrary droned high overhead. Hundreds of B-17s, their 4 turbos emitting a distinctive high-pitched whistle that became a sound of dread for those on the ground, operated flawlessly in the frozen stratosphere. The Americans had not just made the turbocharger work. They had perfected it and mass-produced it. They had solved the unsolvable. This was the intellectual wound that festered in the heart of the German engineering corps. It was a direct challenge to their self-proclaimed technological superiority. To solve this riddle, to understand how the plumbers had bested the artists, they needed to get one of these devices onto their laboratory tables. Their chance came on a cold, overcast day, December 12, 1943. The target for the American 8th Air Force was the vital port of Emden. Among the hundreds of bombers lumbering into the hostile skies was a B-17F from the 100th Bomb Group, a unit already infamous for its heavy losses, grimly nicknamed the Bloody 100th. The aircraft's name painted on its nose was Wolfhound. Its pilot, First Lieutenant Paul Flickinger, was a steady hand, but fate had already marked his aircraft for a different mission. Over the target, flak tore through the sky. A shell exploded near Wolfhound, sending shrapnel ripping through its No. 3 engine. It began to trail smoke, the propeller windmilling uselessly. Another engine began to run rough. The Fortress, now wounded and struggling, could no longer keep pace with the tight protective formation. It began to fall behind. In the brutal calculus of the air war, a lone crippled bomber was a dead bomber. Luftwaffe fighters, like sharks sensing blood, would pounce on any straggler. Flickinger knew his only hope was to seek sanctuary in a neutral country. He set a desperate course for Sweden. But with his navigation equipment damaged and fighting to control the wounded giant, a critical error was made. As he descended through the thick cloud layer, hoping to see the peaceful landscape of Sweden, the airfield that emerged from the gray mist below was not neutral ground. It was the bustling, heavily defended Luftwaffe fighter base at Leeuwarden in occupied Holland. There was no choice. With the landing gear refusing to lock, Flickinger brought Wolfhound in for a textbook belly landing. The massive aircraft skidded across the grass field in a long, screaming shower of dirt and sparks, the groaning protest of tortured aluminum echoing across the airfield before it finally shuddered to a halt. German soldiers and airmen surrounded the plane, weapons raised. For the 10-man crew of Wolfhound, the war was over. For the top minds of the Third Reich, the war for the secrets of the stratosphere had just begun. The news flashed through the Luftwaffe high command with the speed of an electric current. A nearly intact B-17, the prize, delivered directly to their doorstep. Within hours, a team of specialists from the Wanderzirkus Rosarius, the Luftwaffe's elite flight testing unit, was en route to Leeuwarden. When they arrived, they circled the downed bomber with a sense of awe and reverence. It was like paleontologists discovering a living dinosaur. They walked around it, touching the aluminum skin, marveling at its sheer scale. They noted the battle damage, the flak holes, the cannon strikes, a testament to the ruggedness of its design. This was not a laboratory specimen. This was a battle-hardened warrior that had been brought down not by a fatal blow, but by 1,000 cuts. The first order of business was to make the prize flyable. German technicians, working alongside engineers from the Boeing company's own pre-war German counterparts, swarmed the aircraft. They meticulously repaired the damaged engines, patched the fuselage, and serviced its complex systems. The task was completed with astonishing speed and professionalism. Within weeks, the American insignia was painted over with the stark black cross of the Luftwaffe. Its original serial number was replaced with the German code A3+CE, and then, one day, with German test pilots at the controls, Wolfhound took to the skies again, this time as a ghost in its own machine. The aircraft was flown to a secret test facility at Rechlin, the German equivalent of Area 51. Here, the true dissection would begin. Every component was to be studied, every secret unveiled. The initial flight reports from the German pilots were a mixture of professional criticism and grudging admiration. They found the controls heavy and unresponsive compared to their nimble fighters. They considered its overall performance sluggish, but they could not deny its incredible stability as a bombing platform and its astonishing ability to absorb punishment. Most importantly, as they pushed the aircraft higher, they experienced the magic they had only witnessed from afar. As they climbed past 25,000 feet, the point where their own fighters began to struggle, the B-17 felt as if it had been reborn. The 4 Wright Cyclone engines, fed by the tireless turbosuperchargers, did not falter. They sang a smooth, powerful, and constant song. The German pilots, wearing their own advanced oxygen systems, pushed higher, into the deep dark blue of the sub-stratosphere. 28,000 feet, 30,000 feet, 32,000 feet. The aircraft performed flawlessly, cruising with an arrogant stability in an environment where their best interceptors would be hanging on the edge of a stall. It was an unnerving, humbling experience. They were piloting a machine that operated on a different set of rules. Now, the engineers had to find out what those rules were. The aircraft was rolled into a hangar, and the most brilliant minds in German aviation began their work. They were determined to strip away the aluminum skin and lay bare the soul of the American war machine. They started with the systems they understood, analyzing the defensive armament, the hydraulic systems, the famous Norden bomb sight. They produced thousands of pages of reports, hundreds of intricate drawings. But all of this was merely the appetizer. The main course, the object of their deepest fascination, was bolted to the underside of each engine, the 4 General Electric B-22 turbosuperchargers. They were unbolted with the care of surgeons removing a precious organ, each one labeled and transported to the inner sanctum of the materials science laboratory. The moment of truth was at hand. They were about to look inside the box, to solve the riddle that had haunted them for months. They believed they were on the verge of a breakthrough that would level the playing field, a discovery that would allow them to reclaim the high ground. They had no idea that what they were about to find would not be a key to victory, but a death sentence for their own technological ambitions. The laboratory where the General Electric turbosuperchargers were taken was the heart of the Third Reich's technological ambition. It was a place of sterile white walls, humming machinery, and an almost religious devotion to scientific inquiry. Here, Germany's leading metallurgists, thermodynamicists and engineers, men who had pioneered jet and rocket technology, gathered to unlock the American secret. The 4 turbos, cleaned and mounted on sterile steel workbenches, sat under the harsh glare of the overhead lamps. They looked surprisingly unassuming, like oversized industrial plumbing fixtures. There were no visible signs of exotic technology, no hint of the performance they were capable of. To the assembled scientists it was a black box, and they were about to force it to reveal its contents. The lead scientist on the project was a man named Dr. Hans Scherer, a brilliant pragmatic metallurgist who had made his name developing the alloys for German cannon barrels. Scherer was not a man given to flights of fancy. He believed in empirical data, in stress-strain curves, and in the cold, hard facts of the periodic table. He viewed the American turbocharger with professional skepticism. His team's initial analysis, based on wreckage, had suggested the Americans were simply tolerating a high failure rate, that they were willing to sacrifice engines and crews for high-altitude performance. He believed his team would find evidence of this compromise, signs of metal fatigue, heat stress, and design shortcuts. He expected to confirm his own nation's superior, if more cautious, approach to engineering. The dissection began with a meticulous, almost reverent precision. Each nut, bolt, and clamp was carefully removed, labeled, and photographed. The outer casings were lifted away, revealing the inner workings. The cold side compressor was the first to be fully exposed. It was a beautifully milled impeller, designed to scoop and sling vast quantities of air. The German engineers noted the precise curvature of the blades and the tight tolerances of the housing. It was high-quality work, certainly, but nothing fundamentally beyond their own capabilities. They catalogued its dimensions, calculated its volumetric efficiency, and moved on. The true mystery, they knew, lay on the other side of the central shaft, in the fiery heart of the machine. With great care, they detached the exhaust manifold and exposed the hot side of the turbo, the turbine assembly. A collective quiet intake of breath went through the room. The turbine wheel itself was a small, intricate masterpiece. It was about the size of a dinner plate, composed of a central hub from which dozens of small, gracefully curved blades, they called them buckets, protruded. But it was the condition of the wheel that stunned them. This turbocharger had come from Wolfhound, an aircraft that had flown dozens of combat missions, enduring countless hours of extreme thermal and mechanical stress. Yet the turbine blades showed almost no signs of the degradation they had expected. There was no visible evidence of the metal creep that had plagued their own high-temperature experiments. The edges of the blades were still sharp, the complex curves still perfect. They looked as if they had been forged the day before. Dr. Scherer ran a gloved finger over one of the blades. It felt impossibly smooth. This was not the result of a high failure rate. This was the result of a material that was seemingly immune to the hellish environment in which it operated. The skepticism in the room began to evaporate, replaced by a tense, urgent curiosity. The primary question was no longer how the Americans were making it work, but what they were making it out of. The turbine wheel was carefully removed and taken to the materials analysis lab, the inner sanctum of the facility. This was where the secrets of enemy technology were laid bare at a molecular level. The first step was a non-destructive X-ray fluorescence analysis to get a basic chemical makeup. The technicians gathered around the hooded machine, waiting for the initial readings to print out on the ticker tape. As the paper began to emerge, a junior technician read out the primary elements. Iron content, low, very low. Primary element appears to be nickel. A murmur went through the assembled scientists. nickel was a known quantity. The Germans themselves used nickel-based alloys in high-stress applications. It was expensive and increasingly scarce, but not unheard of. The next major element was chromium, also expected, as it was essential for corrosion and heat resistance. So far, the alloy seemed to be a high-grade but conventional nickel-chrome steel. Shearer nodded, his initial theory of a high-quality, but fundamentally understandable material seemingly confirmed. But then the spectrograph began to identify the rarer, trace elements, the alchemist's ingredients that give an alloy its unique properties. The technician's voice faltered for a moment as he read the next results. Detecting significant quantities of cobalt, the atmosphere in the lab changed instantly. Cobalt was a different beast entirely. It was a strategic metal of the highest order, a magic ingredient known for its ability to maintain strength at incredibly high temperatures. The German jet engine program, the pride of the Reich, was starving for cobalt. Their top engineers had to design engines with hollow, air-cooled turbine blades, incredibly complex and difficult to manufacture, precisely because they lacked the cobalt-rich alloys that would allow for solid blades. To find it in a mass-produced American piston engine component was startling. It was like discovering your opponent in a knife fight was casually wearing a suit of armor you didn't even know existed. But the final blow was yet to come. The machine clattered for a few more seconds, then printed out the last major alloying element. The technician stared at the paper in disbelief before looking up at Dr. Shearer. "Sir," he said, his voice barely a whisper, "the analysis shows a high percentage of tungsten." If the mention of cobalt had silenced the room, the word tungsten sucked the very air out of it. Tungsten was, to the German war machine, a metal more precious than gold, more vital than platinum. It was the key ingredient in the high-speed steel needed for machine tools that cut the armor for their tanks. It was the core of the Panzerschreck armor-piercing rounds that were their only hope against the endless waves of Soviet T-34s. Every gram of tungsten was controlled by the highest levels of the armaments ministry. The idea that the Americans possessed not only the industrial capacity, but the sheer audacity to put this hypercritical strategic metal into a mass-produced component of a bomber engine was not just a technical revelation, it was a psychological body blow. It spoke of a wealth of resources so vast, so far beyond their own constrained reality, that it seemed to border on the fantastical. Dr. Shearer took the report himself, his hands trembling slightly. He reviewed the numbers. They were undeniable. This was not a nickel-chrome steel. This was a true superalloy, a complex fusion of nickel, chrome, cobalt, and tungsten, a material scientifically engineered to do one thing: defy the laws of thermodynamics as they understood them. He looked from the paper to the small, insignificant-looking turbine blade sitting on the examination table. It no longer looked like a piece of an engine. It looked like a message. The message was clear. Your best is not good enough. Your rarest materials are our standard components. The war you are fighting is not just against our soldiers and our machines, but against our entire industrial ecosystem. And it is an ecosystem that you cannot possibly comprehend, let alone match. In that moment, the entire German engineering philosophy, built on the idea of superior craftsmanship and refined design, shattered against the hard reality of American industrial power. The Germans were playing chess, meticulously planning each move with their beautifully carved precious pieces. The Americans were playing checkers, but they were doing it by flipping the board over and burying their opponent under an endless, unstoppable avalanche of new pieces. The turbine blade was proof that the Americans could make their checkers out of the same material the Germans used for their kings and queens, and they could make millions of them. The initial shock gave way to a frantic period of analysis. The Germans had to know everything. They subjected the alloy to extreme stress tests, heating it in ovens until it glowed white-hot, then putting it in centrifuges to simulate the incredible forces of rotation. The alloy refused to fail. It held its shape, its integrity, at temperatures and stresses that would have turned their own best steel into molten taffy. They had captured the American machine, but the secret inside it was written in a language of material science they could read but could no longer afford to speak. The final damning report was compiled by Dr. Shearer himself. It was a document stripped of all emotion, a cold, factual analysis of their findings. It concluded that while the design of the General Electric turbocharger could be replicated, The material used for its turbine stage was impossible for Germany to mass produce under wartime conditions. The report stated that dedicating the required amounts of cobalt and tungsten to a turbocharger program would necessitate the complete shutdown of critical tank armor and ammunition production lines. It was a choice they could not make. They were trapped. The prize they had so desperately sought had turned into a poison pill. It had not given them a weapon. It had given them a profound and unshakable understanding of their own impending defeat. They now knew the secret of the high frontier, and the secret was that it would never belong to them. The conclusions of Dr. Scheerer's report landed like a silent thunderclap within the highest echelons of the Luftwaffe and the Reich Air Ministry. The document, classified at the highest level, was a stark and sober admission of technological defeat. But the German spirit, particularly its engineering corps, was not one to simply capitulate to a problem of resources. The report did not end the effort, it merely changed its direction. The prevailing attitude, championed by figures like Ernst Udet and Willy Messerschmitt, was that if brute force metallurgy was a path denied to them, they would simply bypass it with superior, more intelligent design. They would answer America's industrial might with German genius. This decision initiated a period of feverish, almost desperate innovation. Since they could not replicate the American turbocharger, they would perfect their own solutions to the point of absurdity. The new directive was to create a mechanical supercharger system so advanced, so powerful, that it could match the turbo's performance through sheer mechanical perfection. This was not just an engineering challenge. It was a matter of national and professional pride. They would prove that a finely tuned watch could be more effective than a crudely powerful sledgehammer. The result was the creation of some of the most complex piston engine induction systems ever conceived. Engineers at Daimler-Benz and Junkers designed multi-stage, multi-speed superchargers that were masterpieces of complexity. A typical system would involve a first-stage supercharger to compress the air, an intercooler to reduce its temperature, and then a second-stage supercharger to compress it again. The entire system was governed by a barometric pressure-controlled hydraulic clutch that would automatically shift between different gear ratios as the aircraft climbed, attempting to provide the optimal amount of compressed air at every altitude. It was a symphony of gears, clutches, and fluid dynamics, an attempt to replicate the turbo's elegant, self-regulating performance through a dizzying array of moving parts. But every component in this mechanical ballet added another verse to a tragic song of diminishing returns. The systems were incredibly heavy, robbing the aircraft of agility. They were notoriously temperamental, prone to catastrophic failure if not maintained with absolute precision. And most critically, they remained parasites. The sheer force required to run these massive superchargers at high altitude could consume up to 300 horsepower from the engine itself. The engine had to burn a huge amount of its own power just to help itself breathe. The German engineers were trapped in a vicious cycle. To get more power at altitude, they needed a bigger supercharger, which in turn required a more powerful engine to drive it, which then became heavier and needed an even bigger supercharger. This philosophical dead end was perfectly embodied in the high-altitude fighters they developed to counter the B-17, aircraft like the Messerschmitt Bf-109G with its pressurized cockpit, or the later long-winged Focke-Wulf Ta-152H were specialized thoroughbred machines. In the hands of an elite pilot, they were formidable, but they were also hothouse flowers, delicate and unforgiving. They demanded constant expert maintenance and could only be produced in small boutique numbers. They were the perfect expression of the German engineering creed, a handful of exquisite, beautiful, and ultimately inadequate solutions to a problem of overwhelming scale. Meanwhile, in the United States, a different philosophy was proving its dominance. The American approach, born of a culture of mass production and pragmatism, was not to build the perfect handcrafted weapon. It was to build tens of thousands of good enough weapons that were reliable, rugged, and easily repaired in the field by a 19-year-old mechanic with a wrench and a can-do attitude. The B-17 itself was a product of this. It wasn't the fastest or the most agile bomber, but it was tough as nails, bristling with defensive guns, and could be churned out by the thousands. The turbocharger was the secret ingredient that elevated this good-enough philosophy to a level of strategic dominance. It allowed this rugged, mass-produced machine to operate in an environment its more refined adversaries could not consistently reach. It was a force multiplier, a simple, brilliant device that transformed the entire strategic equation. While German engineers were losing their battle in the laboratory, the Luftwaffe's Circus Rosarius continued to use the captured Wolfhound. The aircraft became a macabre celebrity within the German Air Force. It was flown from one fighter base to another, a traveling exhibit of the enemy's primary weapon. The objective was to demystify the fortress, to teach German pilots how to kill it. The circus's leader, Theodor Rosarius, would lecture pilots, using the actual B-17 as a visual aid. He would point out the blind spots in its defensive armament, primarily from the 12 o'clock high position. He would demonstrate its ponderous turning circle and explain the best way to execute a high-speed slashing attack. The German pilots would stand on the tarmac, staring up at the giant American machine, its familiar shape now unsettlingly marked with their own black cross. They would then climb into their own fighters and conduct mock attacks against it, practicing the techniques Rosarius had taught them. On the surface, it was an invaluable training exercise, but it had a corrosive, unintended consequence. As the German pilots formed up alongside the B-17 and escorted it into the high altitudes for these training exercises, they experienced the technological gap firsthand. They felt their own finely tuned engines begin to labor as they climbed through 25,000 feet. They watched their temperature gauges creep into the red. They felt the controls of their fighters turn heavy and unresponsive in the thin, unforgiving air. And all the while, Wolfhound would cruise alongside them, serene and unbothered, its 4 turbos whistling a quiet song of superiority. The training taught them how to attack the fortress, but it also filled them with a deep, gnawing sense of dread. The aircraft was no longer an abstract target on a map. It was a real, tangible beast, and they could feel its inherent power and resilience. The mock attacks reinforced a terrifying reality. To kill a B-17, a pilot had to fly his own aircraft at the absolute ragged edge of its performance envelope in an environment where he was at his most vulnerable, and expose himself to the concentrated fire of a dozen heavy machine guns. The captured B-17 became an echo in their own machine. It was a constant flying reminder of the enemy's seemingly limitless resources and technological advantage. The impossible alloy in its turbines was a secret they all now shared, a piece of battlefield lore that whispered of American alchemy. The machine that was meant to give them an edge instead became a symbol of their own creeping obsolescence. By 1944, this psychological and technological gap had become a gaping chasm. The lessons learned from Wolfhound were tragically irrelevant in the face of the new reality. The problem was no longer how to attack a single B-17. The problem was how to survive an attack from 1,000 of them. The American industrial engine had hit its stride, and the skies over Germany were now filled with vast geometric formations of bombers, each one a flying fortress, each one protected by the simple, unbeatable magic of the turbocharger. The top minds of Germany had successfully stolen the enemy's machine. They had taken it apart and learned its every secret. But in doing so, they had only confirmed a truth they could no longer escape. They were fighting a war they had already lost. The proof was not in a battle report, but in a quiet hum at 30,000 feet, a sound of power they could hear, could analyze, but could never ever replicate. The year 1944 was the year the sky fell on Germany. The theoretical knowledge gained from the dissection of Wolfhound and the practical experience of flying alongside it were now rendered tragically academic. The war in the air was no longer a series of duels between knights of the sky. It had become an industrial, almost mathematical process of annihilation. And America had solved the equation. The 8th Air Force, which had once struggled to put a few hundred bombers over a target, now launched 1,000 bomber raids as a matter of routine. These were not mere air fleets. They were flying cities of aluminum and death, vast, self-defending aerial armadas that blotted out the sun. For the German fighter pilot on the ground, the air raid siren was no longer just a warning. It was a prelude to witnessing a force of nature. He would watch the contrails begin to etch their white lines across the deep blue canvas of the stratosphere, a geometric pattern of terrifying scale and precision. Knowing he had to fly up into that meat grinder, everything the German engineers had feared and the pilots had viscerally felt was now magnified 1,000 times over. The battle for the high ground was over. The turbosupercharger had not just given the B-17 an advantage. It had created a new, untouchable battlefield where the Americans could operate with near-total impunity. From this stratospheric sanctuary, they began the systematic and remorseless destruction of the Third Reich's ability to wage war. The primary targets were the nerve centers of German industry. The ball-bearing plants at Schweinfurt, vital for every moving part in the German war machine, were repeatedly hammered until production ceased. The massive aircraft factories at Regensburg and Gotha, where Germany's advanced fighters were born, were reduced to twisted skeletons of steel. Most critically, the synthetic oil refineries at Plestis and Leuna, the lifeblood of the Wehrmacht's mechanized divisions and the Luftwaffe itself, were relentlessly attacked. Each successful raid was a verdict delivered from 30,000 feet, a verdict made possible by the impossible alloy in the heart of the American bombers. The Luftwaffe fought back with a courage born of desperation. Pilots, many of them barely out of their teens, would climb into their straining fighters and throw themselves at the bomber streams. They developed terrifying new tactics, like the head-on attack, flying directly into the teeth of the fortress's forward-facing machine guns, hoping for a quick kill before being shredded. They equipped their fighters with heavy cannons and unguided air-to-air rockets, turning them into slow, unwieldy bomber destroyers. But these were the actions of a force that knew it was technologically outclassed. They were trading their best pilots and finest machines in a brutally unfavorable exchange rate, and now the bombers were no longer alone in their high-altitude kingdom. The final nail in the Luftwaffe's coffin arrived in the form of the North American P-51 Mustang. Equipped with its own advanced two-stage supercharger and enormous fuel capacity, the Mustang could escort the bombers all the way to Berlin and back. It could climb with the German interceptors, outturn them, and outfight them in their own backyard. The German pilot, after a grueling, oxygen-starved climb to reach the bombers, would now find himself swarmed by packs of these deadly little friends. The sanctuary had become a hunting ground, and the hunters were now American. The captured B-17 Wolfhound faded into irrelevance. Its secrets were now common knowledge, a bitter pill the Luftwaffe had already swallowed. It spent the rest of the war as a transport and liaison aircraft, a lonely ghost haunting German airfields, a constant physical reminder of the prize they had won and the war they had consequently lost. When Allied troops overran its final airfield in 1945, they found it sitting derelict, a forgotten trophy of a bygone struggle. The end of the war was not just a military surrender, it was an ideological one. The German philosophy of achieving victory through small numbers of exquisitely crafted, technologically superior wonder weapons had been definitively crushed. The Me-262 jet, while a revolutionary aircraft, could not save an industry that had no fuel to refine and no factories to build in. America had proven that the Second World War would be won by the nation that could produce the most reliable, rugged, and overwhelmingly numerous weapons. It was a victory of logistics, of resources, and of a pragmatic production philosophy that the world had never before seen. In the final analysis, the story of the stolen B-17 is the story of that unbridgeable gap. The top minds of Germany, in their moment of triumph, had not stolen a secret weapon. They had stolen a mirror, and in that mirror they saw a reflection of their own limitations. They saw a nation so rich in resources that it could afford to build its workhorse machines out of materials they reserved for their most precious prototypes. They saw a nation so industrially powerful that it could solve a problem of advanced metallurgy, not for one experimental engine, but for 100,000 of them. The turbosupercharger was more than just a piece of technology. It was the physical manifestation of American exceptionalism in the 20th century. It was the product of a system that combined free-thinking innovation from companies like General Electric, vast natural resources, and an unparalleled ability to mobilize its industrial workforce to achieve a singular goal. The Germans could analyze the hardware, but they could never replicate the system that produced it. After the war, the world moved into the jet age, an era built on the very principles of turbine technology that the B-17's turbo had helped to master. The lessons learned in keeping those small, red-hot turbine blades from disintegrating at 30,000 feet directly paved the way for the mighty jet engines that would shrink the globe and carry humanity to the edge of space. The echo of that high-pitched whistle from the skies over wartime Europe can still be heard in the roar of every modern jetliner. The story ends where it began, with an idea, the idea that a nation, when pushed, could achieve the impossible. The top minds of Germany stole a B-17, and in doing so, they discovered a secret they knew they could never copy. You cannot reverse engineer a nation's will. You cannot replicate its spirit. And you cannot win a war against an enemy who has not only mastered the battlefield, but has also mastered the very elements from which the tools of victory are forged.